Ora si registrerà la conferenza.
As the other time, we noticed that many people entered during the first 3 minutes, so just a little bit of patience, just 2 minutes, and then we will start. Welcome to everybody. Last time we were around 170 attendees. Now we are around 100. Just wait a little bit more just to check what is more or less the number of attendees today. $100 in this moment, great. Another minute and we start. Okay, I think now it's the right moment to start. So welcome again to all of you for this third step of our journey. This is the third webinar of a series of 7 to discover the IME offer. We are, as I was saying, in this moment we are 110, 11 people, attendees. So today what we'll talk about? Today we will talk about power quality. In particular, we will have an introduction about, let's say, the theory around this subject, and we will discover then what we can offer as IME as a solution, so as products to get kind of information from the electric network. So together with me today there is Stefan, of course, who is the main speaker, who will do all the technical explanation. Then there is Maurizio and Paolo that will answer as usual to your questions in the chat that you can find on the right of your screen. So please feel free to make your questions, write your questions in any moment in the chat. You will receive immediately the answers. Okay, Stefano? So the agenda, there will be, okay, after my quick introduction, we will see what Stefano wrote, old school lessons. This means a little bit of literature, a little bit of theory about the subject, because the quality of quality is a subject quite huge and it's important to recap the main basics that are the basics on which our products are engineered. Then we will go in deep on the presentation of the Nemo 96EA, our power quality analyzer, which is panel mounted. We will also dedicate a slide to our DIN rail mounted solution, which was realized before the Nemo 96EA and had quite a good success in the Nordics. Then we will see the question and answer part. So we will answer again to the main questions that you will do in the chat, and if you will have further questions, we will be there to answer. Okay. So this is a slide just to recap our journey. So we started in the first webinar with the energy meters, in particular with the new series of energy meters that we have just launched. On energy meters, I have also a good news in the sense that the MBUS versions of the energy meters that will be launched, the new version in a second step, still to define. The current version of MBUS energy meters is open for orders, so you are free to also forward place your orders on our current range of MBUS energy meters. Then we saw last time in the second webinar all our range of multifunction meters. Today, as I said, we will see one device in particular of this range, which is, as you can see in the diagram, is the top of our range, because I think you know very well, professional power quality analyzers in the market are very expensive. So actually, this is an affordable power quality analyzer, which is let's say the top of our range. Why it's the top of our range? Because it is able to measure those parameters related to power quality that normally our other multifunction meters are not able to measure. So now I leave the explanation, the technical explanation, to Stefano, and I hope you will enjoy today's session.
Thanks, Matteo. So, hello and welcome to our third webinar. As already said by Matteo, I'm Stefano Chierichini, Technical Commercial for the export part of the IME brand. Today we will present our quality analyzer, but let's start with an introduction of the harmonics phenomenon affecting the electrical networks. So, why we talk about harmonics, especially now and not in the past? Let's talk about it today because the design rules do not change, but the result of the electrical project are influenced. It therefore becomes essential to know the harmonics content in your network, from how it is generated to how it is distributed, and as evolution of the equipment has made this problem inevitable. Harmonics are created from a non-linear loads or generators. The terms non-linears identify a load which, when passing a perfectly sinusoidal signal, disturbs it and change it into a signal that is not entirely sinusoidal. Some examples are a rectifier and among of the most common, the inverters. While for a non-linear generator is a generator which in fact generates a signal that is not perfectly sinusoidal, such as static generators used into the photovoltaic inverter. In the image, we can see an example of this disturbed sinusoidal signal. But how we have that waveform. Here, the Fourier's theorems help us. I don't want to bore you about the theory, but let's say that the waveform is nothing more than the sum of multiple frequency sinusoid of the fundamental. So we have more than a sinusoid that sum to the fundamental one. The graph that we see previously was in the time domain. But if we move from the time domain to the frequency domain, we get the histogram, which surely you would have seen, called the harmonic spectrum. So with this diagram, it is very simple to understand the weight of the harmonics present in our network. Well, if you want to go in deep for this argument, in this presentation that you can download after this webinar, there will be other slides about it, so you can go in deep and improve your acknowledgement. So is an example of a system where harmonics can be generated which disturbed our network. As I said, rectifier, welders, fluorescent lamps, or a simple PCs or printer distort the waveform and propagate it through the network and towards other users. But what are the indicators used to evaluate how really disturbed is my waveform? Well, among these we found the power factor, the crest factor, the frequency spectrum, the distortion power, and the harmonic distortion rate. Before I continue, I would like to make a small focus on the power factor. This value is identified as a ratio of active power to the apparent power. Another value that you usually, normally you heard is the cost phi. This other value is also defined as the relationship between the active power and the apparent power, but of the fundamental, therefore not taking a full account of the harmonic content. This is to tell you that the cost phi in presence of the harmonics will always have a higher value than the power factor. Returning to the topic, we find that the power factor represents the phase shift respect to the fundamental, and it is necessary to know it and evaluate the right power supply. The crest factor represents the relationship between the value of the wave crest and the actual value. This value is important to understand how much current absorbed by the system could generate problems. The frequency spectrum highlights the decomposition of the signal and offer a quick view of the harmonics and their weight. We therefore arrive at the harmonic distortion rate. It's fundamental for analyzing the disturbance introducing into the network and understanding the causes. The values are in percentage and are the ratio between the value of the single harmonic and the fundamental. But what values should be worried about it? For the THD of the voltage, the THDV, if the value is within the 4%, it is considered normal. The problem begin to exit if this value reach up the 80%. So there may have equipment malfunctions. Over the 80% is common to have problems and should be need a system that compensate this harmonic content. However, for the current, within the 10%, we must not worry, is considered normal. Over and up to the 50% could develop an overheating of the power lines. Therefore, it will be advisable to increase the extension of the cable used. While if we exceed the 50%, we should analyze the problem in deeply, and this also compensate with the separate system this harmonic content. Small mention goes to the size of the neutral conductor, which if we have an harmonics from 50% to 33%, we must have the same section of the phases. Beyond this value, it is necessary to increase the section to the neutral conductor. Well, now we have introduced the harmonics, but what are the main effects that afflict the equipment or the hardware in general, and so on? So, starting from the transformers, the current circulating in the winding can generate, as mentioned, a heating due to the Joule effect, or loss in the iron, due to the parasite currents. All these events turn into a loss of system efficiency. And obviously, all these events influence to an economical side. Overheating causes energy to lose, which leads to a greater demand of energy. So, more demand of energy, higher the bill. In Italy, but also I think in other many regions, utility tax in industry that have a power factor of less than 0.95. This is because utilities give you energy that you waste, pass me the term waste, as I said, for example, in heating, and that utility have a cost for maintain and upgrade their power plants. Furthermore, as mentioned, one of the resolutions for the harmonics counter is to increase the section of the cables and the power sources, but therefore other costs. Another thing, a study of the Canadian Electricity Association proves that the harmonics content can reduce the life of the instrumentation by up to 32%, for example, for the single-phase appliance. Another factor is to remember is the safety factor. If you don't have the adequate safety equipment, you may run into loss of continuity of the services due to the untimely trips. So, how should we behave in the most serious cases? Well, there are methods to limit the propagation of the harmonic content in the line, especially in case of the new installation. One of these is to position the load that could generate this past midterm pollution load as close as possible to the energy source. It is certainly more economically dispensing to separate the power supply or to insert a special transformer or inductor into the line capable of power factor correction to the network. Mention goes absolutely to the active, passive, and hybrid filter. Very quickly, the passive filter compensates the reactive energy. The active filter have a very high and precise frequency action range. The hybrid one instead combined the performance of the two filters. Well, all of this makes us to understand how is fundamental to know the entire system to allow us to economically save and have an efficient system. The AN 50160 was recently introduced, which define the main characteristic of the voltage at the terminal of the network used public low, medium, or high voltage in alternate current under normal operating condition. These characteristics are defined in frequency, amplitude, waveform, and symmetry of line voltages. Therefore, are defined phenomena or events. Of these phenomena, we find the dips, which are a rapid and temporary reduction of the voltage to value the approximately 90% of the nominal voltage. The dips start when the voltage values go below this threshold and end when it's turned above this threshold. Generally, they are caused by an ignition of a large load, such in your home, for example, air conditioner, microwave, oven, air dryer, etc., etc. And they could affect the functioning, for example, of computer or robots. Another phenomenon is swell. Unlike the dip, it is a 10% increase above the nominal voltage of the system. As with dip, it is generally caused by turning a EV load on or off. However, the voltage, if the voltage rise is more dangerous, as it could damage the hardware connected to the network. The most visible case, more than the other because it shut down the equipment, is precisely the voltage interruption. Normally is defined as an interruption when the voltage value drops rapidly below the 5% of the nominal value. Obviously, this can lead to damage the equipment as well as cost to restart the entire system and its consequences. Another phenomenon is the rapid voltage change. Is a type of voltage fluctuation defined as a quick transition in RMS voltage occurring between two steady states, and during which the RMS voltage does not exceed the dips or swell threshold. The flickers are, in other hand, are someone connected to the rapid voltage changes, but it is a human perception of a voltage fluctuation, like, for example, a variation of the intensity of the light. Well, we introduce the basis to keep under control and to have a good quality of the energy. The question to ask is, how can I monitor this parameter? The Nemo 96EA come to our help. In addition to the standard parameter already seen in the previously webinar of the Nemo range, such as currents and voltage in class 0.5 according to the AN 61557, and the bidirectionality of the energy count, the Nemo 96EA have a format of 96, and it is capable of recording the energy quality of events previously measured up to 3,000 events for phenomena. You can manage and guarantee the reliability and energy efficiency of your installation in order to minimize the losses due to the disturbance in into the distribution network, as seen during the recap of the energy quality. As is broader than Nemo 96EA+, from it which derives, it can be fitted by a plug-in modules. It is sold in kit with the RS485 communication module, but any communication module as well as other free modules can be installed alternatively. Like the broader Nemo 96EA+, seen the previously webinar, it is possible to use it for low, medium, and high voltage. It is also isolated current inputs. This gives the possibility of using the same current transformer with another instrument or device that require the same current measurement. It is compliant with the following reference you find this in the slide, with the particular attention to the class S reported to the ESC 72586. To better understand, the EN 50160 define the standard for the type of application. the ESE 72586 instead the standard for the product. As mentioned on the back of the instrument, it is possible to install additional module to increase the possibility to connection with and from other instrument. We can mention the impulse output to remote the energy, for example, the analog output module to remote the measurement, and the alarm module to set the threshold, and etc. etc. The programming part of the instrument side remain the same in the Nemo range. To be precise, of the Nemo 96 HD and HD+. By pressing the two central buttons together, you have the access to the setup parameter. With the password 1000, you can set the main parameters such as the type of connection, single phase or three phase, with or without the neutral, and programming the additional modules. Instead, through the password 2001, it is possible to set the ratio of the current transformer and the possible voltage transformer, especially if you use it with a medium and high voltage system. Small attention go to the wiring diagrams. They are very complete. You will find two diagrams for the you find two wiring diagram for the three phase plus neutral because if you have just inserted into your line the same current transformer, you can disassemble your system and use this current transformer because probably you have a scheme like into this wiring diagram. A special mention go also to a test that perform to a combination that perform it's called wiring self-test. It allows you to understand if a wiring error has been made, called wiring self-test. The test perform a possible combination of voltage and current to find the best match. Once found, you can decide to change the wiring or keep it correct via software inside the instrument with the password free. So you can find also in you can download this wiring steps and you find how it is possible to make this self-test. As we say, the Nemo 96EA have an embedded memory. Is able to store data. To be precise, the memory is divided into a three database: energy, real time, and the power quality data. The positive and the negative active energy are saved into the energy database. Same for the reactive and the apparent. For the real time, we found the phase and chain voltage current, the THD, the frequency, and all the powers. For the quality database, on the other hand, we save the events that occurred on the network. Dips, swell, rapid voltage change, and so on. Obviously, with all the quality part we speak, it is easy to understand what is the field of the application. An example are in fact the low, medium, and high voltage panels, where I have to monitor the mentioned parameter and act to improve my system. But it is also an excellent product in those panels where I need to record the parameter of the line and I don't want an additional hardware to store such data. Another tips is to use this in those systems where the utility could cause me problems. In fact, legal action can be taken against the utility if I prove that it is the fault of the utility through an extremely expensive Class A instrument. As I said, our instrument is in Class S, but report the same events of the Class A. This is to say that the Nemo 96EA is the first step of pass me the terms low cost to understand whose fault it is, my system or the utility, and then act or switch to a class instrument, as mentioned, much more expensive. Well, how we download the data in memory? So, very simple. You can use our free of charge software called EDM Evo. The steps to do this are very simple. First of all, open the software and set the IP address of the RS-485 Ethernet interface and on which the Nemo 96EA is installed, and click on the connect. After that, click on search device. The software starts to scan the network to search the instrument. Once found, click on the Nemo 96EA. In this window, it is possible to see the real-time values of the instrument. To go into the setup, enter the password setup in the space indicated and press enter. In this window, select the first indicated as historical. This screen will open. It seems complex, but is not true. On the left side, we find the setting to customize the data to be saved. In the right part, instead, to download the two database of the energy and real-time data. As for the real-time data, it is possible to set a sampling time ranging from 2 seconds to 10 minutes. Same for the energy, from 5 minutes to 50 minutes. The more data I go to save, the less time I go to log, to register. The memory is a FIFO type, so when it's full, it starts to overwrite the oldest data. To download the data, just indicate the period from to, and you need to download the file into a CSV format. While for the quality database, you have to press the power quality button on the top. In this window, you can enter the threshold of the quality parameter and the hysteresis. In the lower part, instead, you can go to download the events by selecting the type of events. For example, dips, and selecting from data and time. All the events stored will be displayed on the right side, and if desired, by pressing the table you find on the top of the bottom of the image, it is possible to put all the events into a tabular format. You will find there the instant that the event occurred, the residual voltage value, the minimum or maximum value reached, if it is a dip as well or a rapid voltage change, the duration of the event, and so on. Everything can be downloaded into a CSV format. Before I finish, I mention goes to the Nemo D4LEF15. It's an instrument created and used upon a request by an important utility in the north of Europe. It maintains the same feature of the Nemo 96EA, but is used only for the low voltage system. It can log the same quality parameter. Well, obviously you can find the brochure, technical note, manual, a communication protocol and the EDM software on our website. So for today, I think I'm going very quickly, and I don't know if I go. I know that I don't speak a lot about the harmonics, but I think, as I say, at the end of the webinar, you can download this presentation and you find more slides about the harmonics content, how is it possible to determine how is important the problem into your line and act consequently.
Stefano, I noticed today we had less questions than usual.
Okay.
But I think this is the moment for every attendee, if there are some doubts, curiosities, etc., to write. We have time. We have still 25 minutes, so please place your questions. So I start with the questions that were made before. So Joao asked the questions. We answered in a private way because it was a questions about earth leakage relay, differential relay. So for everybody, we will have a dedicated webinar on this topic.
Yes,
then
he asked for the two codes, but it's another code. Yeah, I see it.
Okay. Marco asked, can I see the Nemo 96EA power quality information in the energy management software?
Yes, surely. Energy, or better, you say our energy management software, the software for the Nemo 6 range, or in general the new software we introduced the last years, right?
Yes.
So you can add the instrument for the moment. You can add the instrument in the Nemo 96EA, and you see it like a, pass me a term, a normal Nemo 96 HD Plus. I know the marketing working to introduce also the to introduce and download the energy parameter into the system. For the moment, no, you only see the real-time values and the energy values, not the power key. But in the future, I maybe yes.
A question which is maybe related to another, not exactly the topic of today, but it was from Clarel about if we could have more info on the radio add-on module, distances, emitter and receiver.
Okay, if you want, I can send you also a technical note, because I think it's not, don't you find this on the website, but it is 200 meters in open field. So pay more attention when you install this type of radio, because if you have such a robot or instrument that can generate a magnetic field, you can reduce a lot these distances. So it's very particular instrument, and it is used all in very particular situation, in a pass me the term, into a clear field without a lot of magnetic load, magnetic field generated by load.
Okay, from Hugo, can we make the verification of the energy supply as network analyzer?
Sorry, Matteo?
I think the question is, can we make the verification of energy supply as network analyzer? I mean, I think Hugo means that if we can prove that the energy supply is not good from the utility with our device.
Yes, as I say, you can, the Nemo 96EA have the same parameter of a Class A. The Class A is a much more expensive. We speak about 5,000 euro of an instrument in Class A. But as I say, if you go against the utility, you need the Class A. But if you are not sure that is the utility problem or your problem into your system, you can try to install a Nemo 96EA, a low-cost solution, the Nemo 96EA, see the events produced by your utility or your system, and see if it's a good way to buy a more expensive instrument, or probably it's my problem.
A question from Marco related to this topic. Are there future plans to develop a Class A network analyzer?
I think you can answer. I think in the moment, I don't know. Really, I don't know.
Actually, I don't think so, Marco, because actually this is really a niche. If we go on the Class A, it means really the niche of the power quality, and really very expensive products, and really very specialist brands. So I don't think that we want to go that way. We prefer, let's say, to give a first solution for power quality, you with affordable price, use for the mainstream. So our objective is really to have a mainstream offer, accessible and useful to everybody, not to go really on the very specialist, super specialist niche with very expensive devices. Mohammed, is it possible to have offline analysis of the logged information?
Offline analysis.
It means if you, I think if it means that if you are not connected to the device, how can you recover the information?
Okay. As I say, the Nemo 96EA is have the same of in the information of the Nemo 96 HD Plus. So you can find on the display the same parameter. The quality parameter are available only by remote, only by the download via EDM-Evo.
So FIP, what does it mean by possibility of set total harmonic distortion hold?
Can you repeat? Sorry, Matteo.
I think it means if there are some possibilities to set a total harmonic distortion threshold.
A threshold. No, this is not one of the parameter. Because as I say, the THD is a value to maintain under control in real time. So it's very difficult to put a threshold on it. Is more probably to set to put differential relay in type B for this type of events. Really, I never find an application to put a THD, a threshold on THD, because as I say, is a problem that you have or you don't have. If you occurred during your system a problem, is probably is a dispersion of is more an alarm produced by a differential relay, not by a multifunction that a quality analyzer.
Okay.
Because in order to reduce the THD, it's not a value that increases temporarily.
Interesting question from Marco. Can the analyzer measure the harmonics that are generated inside the installation and the harmonics that come from the outside?
Yes, depend when you where you install the instrument. If you install the instrument on the top part, of your installation nearest the power supply, you see also the or better before the interrupt, you see the THD, the harmonics come from your utility. If you install your instrument nearest your load, you see the disturbance created by your load.
From Hugo, can you share an output file of historical events to see the values shown?
Yes, surely. You find after that on a link also a file for this type of events. You find here an example, an image with an example. But as I say, is a CSV file. here. Okay, this is a CSV file. You can open it with Excel, for example, and you find the events, the date and time, what is the maximum voltage or the minimum voltage reached, depends if it dips or when, and so on. You can find at the end, I add also this demo in this link.
Dalibor, any power quality meter with metering accuracy 0.2?
For the moment, no. For the moment, we have also an energy meter, a special energy meter, but for the moment, we have also in class 0.5.
Okay. Lars, can data be retrieved by third-party software or SCADA that a customer already have, or only, or it's necessary to use IDM Evo?
Yes, surely. You can download it a third-party SCADA. There is no problem because the Nemo 96EA work with the Modbus map. So you can find in our website, or you can download it, the communication protocol, and you can find how to download this data.
From Nabil, what is the sampling time to measure harmonics? Can this meter reach microseconds sampling time?
So for the parts of the sampling in the 5 kilohertz, the software, or rather the Nemo, as you can see here, you can sample only the THD. Sorry, take this one. You can store the THD, so the total harmonic distortion, not the single harmonics. If you want, you can via a SCADA, you can store the harmonics content up to the 30 order via a third-party software. So you can go to take the Modbus map, select your the harmonics register you want to store, and make a sample every time you want. You can this data is refreshed every 2000 milliseconds, and it takes the medium values in 5 kilohertz for the 5 kilohertz samples.
So Philip, this question has to do with the display. What if I reach the maximum display of in kilowatt hour?
Depend of the current transformer you put. If you put biggest current transformer, it also change the quantities from kilowatt hour to megawatt hour.
Scale.
Yes, up to 9 digits. So 9 digits of megawatt hour. So it's really a lot. So it depends on the current transformer. More higher is the current transformer ratio, more energy you can store, and it change the quantities.
Okay, from Mohammed, there is a module for RS485. If we add to the meter, then this would make 2 RS485 ports. What scenario would be useful to have 2 ports?
No, you have only one port you can add into the instrument. But there is a workaround for this. For example, if you put one communication port, but 2 interfaces. If you put 2 interfaces like the EF4E011, they can manage the traffic on the bus. So, or better, also with one interface, because the interface is a multi-session interface. So when you reach 2 questions from the SCADA software, or 2 different PLC, for example, this EF4A manage the traffic on the bus, and you reach the right answer from the two answers. So one interface and one multifunction interface.
Okay. From Rajesh, one question is still related to the 0.2 class of precision of accuracy, and you said no, we don't have. The second question is, please suggest class of CT for this Nemo 96EA, because class of CT affects the measure.
Yes, we see in the next webinar how it's important to choose the right current transformer. Surely for a Nemo 96EA, for have a better measure, I will suggest a minimum of class 0.5 current transformer ratio. Surely, if you use a 0.2 class, it's better. But surely you don't have to go to class 1 or class 3 current transformer ratio. Surely class 0.5 or class 0.2 is okay.
Do you have a galvanically isolated port for RS485 in Nemo 96EA?
Yes, the modules have a isolated galvanic module, isolated galvanic input. The modules you sell for the entire Nemo range.
Question related to India situation about electrical network. Is your meter applicable in a line with voltage 440 volts and the frequency 50-60 Hertz?
Yes, no problem. As I say, is the big brother of the Nemo 96 HD+. So it can reach up the voltage of up to 690 volt. And there is no problem for 50 or 60 Hertz.
Does Nemo 96EA have maximum demand feature with cutoff alarm?
Maximum demand, yes, you have it, but I think it isn't a parameter that you can set a threshold. I have to go to see it, but I think it's not one of the parameters that you can set the threshold. You can set on the power, the instant power, apparent, reactive, or active, and so on. But the maximum demand, I think no. This one you can see the maximum demand, but I think it's not one of the parameters you can set a threshold.
Interesting question. Is there a Nemo from Marco, Nemo 96EA kit with Rogowski coils?
No, because as we mentioned the last time, the Rogowski coil is not a panacea for all the system. Rogowski coil are more afflicted. You have a bad measure for a system with a lot of harmonics content. So is help me Matteo, is controproducente, is
counterproductive
to put a kit with a bad measure of Rogowski coil into a quality analyzer that analyze the harmonics.
Clear. Okay, clear. From David, in your opinion, what values of THD and THDV threshold do you think are enough to tell the client has problem and it's necessary to check the installation or install filters?
Yes, I have a next slide about it. You find it THDE and THDV here. Yeah. We have 3 steps for THDV. If you have a problem on THDV, is really a problem, because if you have a harmonic distortion of the voltage, really a huge problem. So you have 3 steps about this. You can find it. Less than 4%, you have no problem. 80%, you have to check. You start to check if you have some problem on your equipment. Above the 80% is probably you have equipment with malfunctions. The same for the THDE. Less than 10% you have normal, because a lot of SSA overheating or a conductor, a small conductor can create these harmonics. If you have a value up to 30%, is possible you have a problem like overheating. And if you have more than 50%, you are surely have some problem into your equipment. You need to start to check your system and find a solution to compensate this harmonics content.
From Josue, can we connect through Modbus or KNX a BMS system?
Yes, we have an interface that converts from RS-45 to KNX, but only for the real-time and energy data. The quality, no. So it's if you connect to this interface, is like a normal Nemo 96 HD or HD+.
From Dimitar, at the moment in Nemo 96EA, we can use only one communication module. Customers are often required to have 2 or more communication modules. Do we have plans for the Nemo 96EA to have the ability for use of 2 or more communication add-on modules?
Okay, just answer to this. There is a workaround. For the moment, no, you can only add one modules. But if you use a multi-session interface that converts from RS-45 to Ethernet, like the EF4E011, it manages the traffic on the line, and you can have multiple question comes from the PLC or the SCADA software and so on, and this interface manages traffic, and you have 2 different answers from the 2 or more answers.
From Marco, is it possible to increase the memory of the Nemo 96EA?
Sorry?
Is it possible to increase the memory of the Nemo 96EA?
No. Because the memory is integrated. For more technical, we have a 80 megabit of memory, but it's not a problem of memory. Is because we have for the power quality 3000 events for phenomenon are a lot. If you have more of this phenomenon, your plants is a totally disaster. So there is a really problem with this. For the part of the real time, I know depend what is your idea of maintain under control. If you put, for example, 2 seconds, as you see in the slide, is you have more or less 1 day of record. I know is low data. You have a low data, but if you put 2 seconds, I think you need this data because you have a problem. You have a problem to check rapidly. So normally you install the Nemo 96EA, you set 2 seconds. At the end of the day, download this data and check if you have a problem. That's why, okay, less data, but more frequently controlled, because if you set 2 seconds, is because you have a problem in your system and you want to resolve this problem.
A question from Rajesh. Regarding Nemo 96EA, if the load is very low, will the accuracy be affected?
depend of the current transformer. It totally depends of the current transformer, because as we say in the next webinar, the current transformers works better if you find the nominal current of the current transformer you choose nearest the maximum current of the load. So for example, if you have 10 amps of load, you don't have to choose 1000 amps current transformer because it works under the 1% of the current transformer. You have to choose a 10 amps or 50 amps current transformer. So the precision of the instrument depend also by the current transformer. If you use the right the current transformer, the precision remain the same.
From David, with eddy currents, you mean parasitic or induced currents?
Sorry, can you repeat, Matteo?
From with eddy currents, I
Yes.
don't know. Yeah, okay.
Parasite current.
Okay. From Michael, kindly advise if we do have now CT for kilowatt hour meter as a 2400 to 5 amp with class 0.2S.
Yes, but we see in the next webinar. Okay.
Yeah. From Hanan, do you have video tutorials how to install and configure this product?
Yes, or better, you can take good question. We had also the YouTube YouTube program. It is not for the Nemo 96EA. It is for the Nemo 96 HD Plus. As we say, Nemo 96EA have the same setup program of the Nemo 96 HD Plus. For the quality, power quality function, you can follow this guide. From DDM, you start and you follow this procedure.
From Boris, how would the result be displayed if you are outside the norm, the standard 160, EN 160?
How would the result be displayed? While we are outside the 50, no, it's inside the norm 50160, and you can download this result by the demo in this with this type of CSV file.
From Lars, is the memory embedded in the Nemo 96EA meter or in an IF96012 module?
No, you don't need the EF96012. It's embedded.
Okay, so I think the question answer time is finished. I think we could conclude with the final slides. So thanks a lot for your participation. Just a very quick from my side information. We are again, I repeat, in phase 2. So warehouse open, shipping, factory open, and increasing the production capacity. So feel free to place your orders. You will receive order confirmation with a live delivery dates. So see you same day, same time next week. Next week we will go in deep with our web server range and the related software for remote monitoring the electrical installations. So see you in 1 week. Thanks a lot for your great participation also today, and have a great weekend, and see you next week. Bye.
Have a nice day. Bye bye.